Hi students, in this video we're going to talk about the properties of functions and linear models. By the end of the video you should be able to graph a linear function, use the average rate of change to identify linear functions, determine whether a linear function is increasing, decreasing, or constant, find the zero of a linear function, and build linear models from verbal descriptions. In order to achieve those objectives, first we need to know what is a linear function. So a linear function you've seen before, and it takes on the form of f of x equals mx plus b, or y equals mx plus b, where m is our slope, or our average rate of change. We can denote this as the change in y over the change in x. Or if we have two ordered pairs, that's y2 minus y1 over x2 minus x1, the slope. B is our y-intercept. So when we look at a function in this format, f of x equals mx plus b, we know that m represents our slope and b represents our y-intercept, or where the function crosses your y-axis. For all linear functions, the domain is all real numbers, negative infinity to infinity, as is the range, meaning we can put any number in for x and we can get any value out for y. Functions that are not linear or cannot be written in the above format are called non-linear functions. Let's think about our linear functions, our lines. When I look at a graph, I could have a line that goes something like the one you see here. As x goes up or increases, my y increases. If this happens, that means you have a positive slope in an increasing function. I could have a line, a linear function, that looks like this one. I'm thinking about what happens as x increases. In this case, as x increases, as I'm looking from left to right on my graph, my y values go down. In this case, my slope is negative. So we have a positive slope example, a negative slope example. I could have a line that goes like this. It's horizontal. So that means every x value I put in, all of my y value is always going to be the same. So as x increases, y is constant. If this is the case, your m is equal to 0. Your slope is 0 on this. And if we think about our formula here, y2 minus y1, for each of these x values, x1, our y value is the same. x2, our y value is the same. So we'd be subtracting the same number on the top there in our numerator, and we would get 0 for our numerator. And a line that looks like this will be in the form of y equals some number c. Now, another line that I could see on the graph is a vertical line. This is not a function. Why isn't it a function? Well, it's a vertical line. It's not going to pass my vertical line test. It'll be of the form x equals some constant, and your slope is not defined. We can use this information to help us summarize what does it mean for a function to be increasing, decreasing, or constant. So we can say a function is increasing over its domain if the slope is positive. Right here we have a positive slope. M is greater than 0. Our function is decreasing over its domain as x increases, y decreases. So our slope is negative, or m is less than 0. We say that our function is constant over its domain if the m, or slope, is equal to 0 and we have a horizontal line. Let's use what we just learned about linear equations to determine an equation for each of these functions, and then we're going to determine if each function is increasing, decreasing, or constant. Remember, a linear equation takes the form of f of x is mx plus b. So we need to find the slope of each line and the y-intercept and then put it together. Let's look at example 1. So I'm looking at this graph here, and I can see that the graph crosses the y-axis at 2. Here's the point 0, 2. So our y-intercept b is equal to 2. I can use what I see on my graph to help me get our slope. I have the point -3, -3. And I have the point 0, 2. I can see that I go over 1, 2, 3, and I go up 1, 2, 3, 4, 5 to get from one point to the next. So my change in y over my change in x is going to be 5, because y is vertical, over 3. So that's my value of m. So here we have f of x equals 5 over 3x plus 2 for our equation. You can see this is a positive slope, so the function is increasing. Let's take a look at the next example. Here we have a line that is horizontal. So because it's horizontal, we already know that this function is constant. We can see that y is always equal to 2. So our slope for this, m, is 0, because we have, for every x value we put in, y is going to be the same. So we'll always have our numerator here as 2 minus 2, no matter what x values we use. So like if we used 0, 2 as one of the points on the function, and then we used 5, 2, our slope formula, we'd have 2 minus 2 over 5 minus 0, or 0 over 5, 0 for our slope m. So we just have our y-intercept. Y equals 2 is going to give us the whole equation for this function because it's constant. It has a horizontal line. For our third example, I can see that as x increases, so as I look from left to right on my graph, y is decreasing. So this is a decreasing function. I'm going to look around my y-axis, and I see that the line crosses the y-axis at 2, so I have the point 0, 2, and my y-intercept b equals 2. To get my slope, I can take my point 0, 2 and identify another point on the line. I have 3, -3. Once again, I'm going to draw a right triangle. And this rise of 1, 2, 3, 4, 5 over my run of 1, 2, 3 is going to give me my slope. Slope, remember, is rise over run. Every time I go forward 3, I go down 5. I'm going to take the sides of the triangle and list them. The height is the numerator. The length, or the run, is the denominator. And it's negative because I can see that the function is decreasing. So that's my slope m. And I get an equation, y equals -5/3 x plus 2. Now that we've done 3 examples together, it's time for you to pause the video. And I want you to write the equation for these 3 graphs and determine whether they are increasing, decreasing, or constant. Pause the video. No peeking. Unpause when you're done. Now that you've tried all 3 problems on your own, you're checking your answers. The first is f of x is 2/3 x minus 2. This function is increasing. Then we have g of x is -2/3 x minus 2. This function, as you can see, is decreasing. As x increases, y decreases. And our last function is constant, and I've named it h of x, and h of x is equal to -2. For any value of x, our output is -2. All the functions we just explored, we found the change in y and we wrote it over the change in x to find our slope. This is called the average rate of change of f of x is mx plus b. The average rate of change is constant for all non-vertical lines. So for all linear functions, you're going to have a constant number for your average rate of change. We're going to explore this looking at graphs and also by looking at tables. Another concept we'll also explore is the zero of a function. The zero is where the graph crosses our x-axis, the x-intercept. To find our zero, we're going to set y equal to 0 and find the value of x. Let's look at both of these with an equation, a graph, and a table. We are going to graph the function g of x is -2/3 x plus 6. We are also going to fill out a table and explore the average rate of change, or change in y over change in x. First, when I'm looking at this function, I can see that my slope, m, is equal to -3/2. I can see that my y-intercept, b, the y-intercept, is 6. So to start off, I'm going to plot my y-intercept at 6. That's the point, 0, 6. And I can put that in my table. When I put in 0 for x, I'm going to get 6 out for g of x, or my y value. I can use this slope to find my next point on my graph. So to do that, I'm going to say every time I go forward 2, because that's my change in x, I'm going to go down 3. You can always take that minus sign and put it in the numerator. So forward 2, go down 3. That gives me another point on my graph. My next point on my graph is 2, 3. I can go over 2 and down 3. And I get the point 4, 0. I can go over 2 and down 3 again. And I'll get another point at 6, -3. We can follow that pattern. If you're ever graphing a line though, you really just need 2 points and then you can connect them. You can connect your points, then make a line that fills your whole graph, and since it's a line and it goes on forever in both directions, make sure you put arrows at the end. When I explore my change in y over my change in x, I do the following. I'll find the difference in my y values, 6 minus 3, and I'll divide by the difference in my x values, 2 minus 0, and I'll get 3 over 2. You'll notice I'll have 3 over 2 for my rate of change between each of these points. This number is constant across the graph. We have now discussed 4 out of the 5 objectives for this section. We've graphed linear functions, used the average rate of change. We've talked about increasing, decreasing, and constant linear functions. We've found the zero of a linear function, but we have not yet built linear models from verbal descriptions. You can click onto the next video to discuss this objective, as well as practice some problems that are similar to what you might see in your homework.